Yeah, here are a couple of examples to illustrate the principle of design based on ideal final result concepts. And I don't know if it was real case, but somebody told me that back in 50s there was some problem with some agricultural problem, I would say, that the crops were invaded by kind of small bugs. So bugs were eating the harvest, and one research institute somehow revealed that if the temperature of the bug is different to the temperature of the environment, then they could fight it. And of course, obviously the problem was how to measure the temperature of the bug. And if you know that in 50s there were no such a complicated tools like spectrometry or some laser schmazer or whatever it is, and you cannot do it with regular thermometer of this size because the mass of bag is incomparably smaller with the mass of thermometer. So when you try to measure the temperature of the bag, definitely you measure the temperature of the thermometer itself. So there is a problem, and well, if you are a standard engineer, possibly you could end up with the design of complicated devices, I say, I don't know, spectrometer or whatever it is, and in order to tell the temperature. But there could be another solution that is almost ideal. And ideally, again, you don't need anything else but what you have only. So ideal bug measurement device is no bug measurement device, but you can measure the temperature with what you have. And obviously you can guess that it is much easier to collect I don't know 1,000 of bugs, because the bugs were the problem, so I don't think there was a deficit of it. So to collect 1,000 of bugs until the mass of the bugs is big enough, and then to use regular thermometer to measure the average temperature. And that solution is beautiful and doesn't require any complicated equipment. And you can save definitely a lot of money for the design and the manufacturing of such a complicated device.